Good morning, one and all. My name is K. Atila. I am pursuing my BTech fourth year in Vignan Institution of Information Technology. During my academics, we are done a project called Vehicle-to-Vehicle Energy Transfer for electrical vehicles. So, the main purpose of this project is we know that in most of the areas are filled with air pollution. So to overcome that problem, some people are come with the solution like electrical vehicles, but there is an disadvantage. It is traveling to the long distances. There is no charging stations. So to overcome that problem, we came with a solution, that is energy transfer from vehicle to vehicle, that is electric vehicle to electric vehicle. So here is the project, and these are the components we are used in this project, and we can see here is the two electrical vehicles. This is the donor electrical vehicle and this is the receiver electrical vehicle, and here is the Arduino board. In that we can it acts as the main controller of the system, and here is the 16:2 LCD with 12C, and in this display we can see the battery voltages, system status and messages, and here is the 4x4 matrix keypad, and it allows user input or control, and it can be used as a start or stop energy transfer and select modes, and here is the voltage sensor module. It is used to measure the battery voltage levels, and it helps Arduino decides which battery is high and when to transfer energy. And here is the relay module. It works as the electronic switch, and it is used to connect or disconnect batteries and control motor operations and enable safe energy transfer. And here is the DC motor. It represents loads or EV wheel system and runs when power is supplied and demonstrate energy usage from batteries. And we can see in the electrical vehicle we placed a batteries, so it provides electricity to the system. So one battery can transfer energy to the another battery. It means energy is transferred from one vehicle to another vehicle. So in that we are this is the DHT11 sensor. It measures temperature and humidity and used for battery safety monitor and prevents overheating during energy transfer. And we are done with the hardware implementation, and another we done a software implementation. So okay, let us see how the working is going on. So now the power supply is given to the Arduino. So we can see here it starts working. In that the temperature values we can see here in the display board, and the voltage value of the vehicle 1 and vehicle 2 also. It's showing vehicle 2 is transferring to the vehicle 1. The energy is transferring from vehicle 2 to vehicle 1. So after pressing the start button, we can see here the maximum percentage 90 degrees. So we can enter 30 to 33 seconds here to transfer the energy from one vehicle to the another vehicle. So the charging is done. So here we can see the hardware implementation of vehicle to vehicle. So we are going with the simulation part. Here we can see the donor side and receiver side. In that we are giving the, for simulation part we are giving the code. We can see that this code is giving to the Arduino. Based on this code we are going to run the simulation part. Start simulation. So you can see here EV to EV charging. In V1 we are having 45 voltage, and V2 we are having 36 voltage. So we can transfer from V1 to V2. It's showing okay. So we can move forward to transfer the energy from V1 to V2. So we are clicking on the star button. So it's showing maximum percentage is 90%. So we can go with the how much percentage we are going to transfer. 10% in 10 seconds. So you can see here charging is done. 36. You can see now V1 is equal to 36 and V2 is equal to 45.